10.3 area of regular polygons. That should also say polygons. Okay, first we have this area of a polygon. Whenever it's not a rectangle, basically a quadrilateral, we have to take what we call is the height, but we actually call it a apothem. So when we have the center of the polygon, so it has to be a regular. Remember, regular means all sides, all angles are the same. From the center of the polygon straight down to the side that creates a 90 degrees, that is called the apothem. So this right there is called the apothem. Now, this dot is called the center of the polygon, and this is the side. So when we're looking at the actual equation that we use, it is the area is equal to 1/2 A times P. Now, A stands for my apothem. So again, the length from the center of the polygon to the edge that creates a 90 degree. P stands perimeter. The perimeter is when you add up all the side lengths of the picture. So again, it's kind of like we're splitting these up into multiple different triangles. That's really what we are doing. So first, before we actually get into this, we have to figure out what's going on in this picture. Now, just like in a circle, whenever we have from the center of a circle to the edge, to a corner, it has to be to a vertex. This is like a radius or a radii. So this radii is talking about that length. From the center to the vertex, that's the radius. This right here, angle 1, is called a central angle. So if I want to figure out what that angle is, in any triangle, in any picture, if I were to draw this circle, one circle is 360 degrees. Now, if I look at this, because I know that these are all equal to each other because it's a regular hexagon, we can take 360, because that's how much a one circle is, and divide it by how many central angles we have. We have 1, 2, 3, 4, 5, 6. And that's not a coincidence. The reason why we have 6 central angles is because we have 6 sides. So if I do 360 divided by 6, I get that angle 1 is going to be equal to 60 degrees. Because again, it's taking that 360 divided by how many sides we have. Now if we actually get into these other side lengths. When you draw this apothem, so right here, this is your apothem. It creates that 90 degrees. It cuts that central angle right in half. That's what an apothem does in each regular polygon. When you create the apothem, it cuts it in half. So since I know my central angle, I can divide that by 2, and that angle right there will be equal to my angle, my angle 3 in my picture, because I'm cutting my central angle in half. Now, there are multiple different ways that you could go about doing this, but when I'm looking at this right triangle then right here, to figure out what angle 2 is, my apothem creates my 90 degrees, my angle 3 is equal to 30, my angle 2, and I know that all my angles in a triangle equal 180 degrees. So I can do 180 minus my 90 minus my 30, and that would be equal to my angle 2. So that would be equal to 60 degrees, my angle 2. And it's the same process that we have for any polygon. So if it's a pentagon, that's when I would divide by 5 first, because there'd be 5 central angles. But again, we'll go over this more and more. So now getting into actually finding the area of a regular polygon. Again, that equation right there is that same one that I drew up here. So when I'm finding the area is equal to 1/2 times A times P. So now looking at this, I know that my A here is equal to 14.5. P is going to be my perimeter. So first I have to figure out, well, if you know what octagon is, then you can just take the side length times 12. But now I have to count. I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 sides. So if I were to add 12 plus 12 plus 12 plus 12 plus 12 plus 12, or else I could do 12 times 8. And because I have 8 sides and each side is worth 12, this perimeter is equal to 96. So my area here is 1/2 times my apothem, which is 14.5 times 96. Again, this is the same type of thing as if I were to draw a bunch of different triangles. So that's essentially what this formula is doing here. So we have 696, and my units here are centimeters, and area is always squared. That's all I have for you in this section. Not gonna lie, the next section, 10.5, does get a little bit more difficult, but in class, we're gonna really practice this information because we're going to have to use this plus SOHCAHTOA in 10.5. And there you have it. You're that much smarter. I'm proud of you. Have a great, have a grand, have a wonderful day.